Hey everyone, welcome to this in-depth Python crash course. In the next 3 hours, we're going to dive into the world of Python, covering everything from setting up your environment to building powerful websites using Django. Whether you're a complete beginner or brushing up on your skills, this video has something for you. We'll start by installing Python and Visual Studio Code, and then explore the essentials of Python programming, everything from control flow statements and functions to working with data types, lists, and tuples. Along the way, we'll build some cool projects together to reinforce these concepts. But that's not all. After mastering the basics, we'll jump into Django, a powerful Python framework for building dynamic websites. By the end of this video, you'll be well equipped to write Python programs and start building websites with Django. So, grab a cup of coffee, and let's dive into the world of Python. In this tutorial, we will learn how to install Python on Windows 10 using the Python installer for Windows. Prerequisites: you will need a computer running Windows 10 with administrative privileges and an internet connection. Step 1: downloading the Python installer. Go to the official Python website to download the Python installer. Under the download menu, you will find the latest version of Python. Download the Python installer by clicking on the button. After the installer downloaded, run the installer to start installing Python on computer. You will find two options at the end of the installer windows. Use administrative privileges when installing py.exe and add python.exe to path. Check the both options. Click on Customize Installation. Click Next and click on Install. Python has been installed on our computer. Visual Studio Code is a lightweight but powerful source code editor which runs on your desktop and is available for Windows, macOS, and Linux. It comes with built-in support for JavaScript, TypeScript, and Node.js and has a rich ecosystem of extensions for other languages and runtimes, such as C++, C#, Java, Python, PHP, Go. To install the Visual Studio Code, just open your favorite browser and search for Visual Studio Code. The first link that will appear is from Visual Studio official website. Click on this link. Once the website is open, you'll see a download button for Windows. Click on this green button to download the executable file. Wait for the download to complete. Once the executable file is downloaded, go to Downloads folder in my computer and run the setup file. Then agree to the license terms and conditions, and click Next. This is the location where Visual Studio Code will be installed on your operating system. If you don't have a good reason to change it, just click Next. On the next window, if you don't want to create a Start menu folder, you can check the corresponding box. However, I'm going to leave it unchecked and click Next. Here are some additional options. If you want to create a desktop icon, click that option. There are some other options, which I will check, and then I'll click Next, and then Install. Visual Studio Code will take a few seconds to install, so I'll wait for the installation to complete. Once the installation is finished, you'll see a setup window. If you want to launch Visual Studio Code immediately after installation, you can leave the checkbox checked, then click Finish. This will launch Visual Studio Code. After successful installation of Visual Studio Code, we will install two extensions in order to run Python code on our editor. The first extension is Python from Microsoft. Click on Install to install the extension. The second extension is Code Runner. This extension is used to run and debug the code on the Visual Studio Code editor. After installing the both extension, click on New File to create a new file. Don't forget to add the py extension at the end of the file, so that our editor treat this code as Python code. After writing the file name, press Enter and select the location of the file where you want to save the file. You can create a new folder as well for your project files. Now, let's start coding by using print statement, which is used to print any message on the console. Just write any text within parentheses to print on the screen or console. After writing the code, you will find the Run button on the right side. Run button will display the output of your code on the bottom window. You can adjust the size of this window as per your need. So guys, this is how we can install Visual Studio Code in our computer to write Python code. If you run into any issues installing Python or Visual Studio Code on your computer, don't worry. You can use the Programize Online Python compiler to run your code directly in the browser, no setup required, making it an easy way to practice without any hassle. Just write the code on the left and hit Run button to view the output of the code. The print function is one of the most fundamental commands in any programming language, used to display output on a console or standard output device. When you write text within double quotes and pass it to the print function, it will display that text exactly as written, including strings, numbers, or special characters. In Python, if you want to print the value of a variable, you refer to the variable by its name without enclosing it in double quotes. For example, if you have two variables, name and age, and you want to include them in a print statement, you can do like this. You can also combine string message and variables to output your desired results, just spare it the string message and variables with a comma. You can also use a more concise method called formatted string literals, or F-strings. By adding the letter F before the opening quote, you can embed variable names within curly braces, allowing for easier string interpolation. Here's how you would do it with f-strings. Using f-strings eliminates the need for commas to separate text and variables in the print statement. It also offers a clean way to format output. Additionally, you can use the newline character \n within a print statement to create line breaks in the output. For example, the following code will print the text on separate lines. These are some of the basic ways to use the print function in Python. With these techniques, you can effectively display output in various formats. Python arithmetic operators are used to perform math calculations like addition, multiplication, or subtraction. For example, if you want to add two values, then you can use plus sign or minus sign to subtract, asterisk sign to multiply, and slash sign to divide. You can also use variables to do math in Python. This means you can store numbers in variables and then use these variables to do your math calculations. You can also store the results in another variable for later use in any part of your project. The Python input function is used to receive input from the user while a program is running. When you use input, the program pauses and waits for the user to type something in. Once the user enters the input and presses enter, the program continues execution, and you can store the input in a variable for further processing. Here is an example. In this code, we're using a variable called name to hold the name the user gives us. Then, we're using the print function to show the name the user entered. Every time this code runs, it asks the user to type something in. Whatever the user types gets stored in the name variable. You can use this name anywhere else in your program because it's saved in a variable. We can also get input in the form of numbers, integers or floats, or text. And of course, we can use these values stored in variables with the print function to get the results we want. Let's explore another example involving user input. We'll prompt the user to input two values, and then print their sum. First, we'll capture the initial input value from the user and store it in a variable called value1. Next, we'll prompt for the second input, storing it in a variable named value2. Then, we'll perform the calculation using the print function to display the total. Now I am going to run this code. We'll input the first and second values. Oops, the code displays the input values together instead of their sum. It indicates that the input function is treating the inputs as text values rather than numerical ones. So, we'll need to convert the input format from text to numbers to enable calculations. We'll use the int function to convert the text input into numerical values. There are several methods to achieve this. The first method involves converting the data type of both variables using the int function and storing the sum in a new variable called total. Then, we'll print the value of total. This approach ensures that our code runs smoothly and displays the result in numerical format. The second method entails converting the data types of the variables by enclosing them in the int function within the print statement. This method will produce the similar results to the first approach. The third approach involves converting the data type immediately after user input by wrapping the input code within the int function. This ensures that the input is converted into an integer before being stored in a variable. The end result remains the same as required. We can utilize the float function to convert the values to floating point numbers. Suppose both value 1 and value 2 variables contain integer values. We'll wrap both variables in the float function to convert their data types to float and store the converted values into two variables called f1 and f2. Then, we'll use the print function to display the sum of both values. Now, we have two results, one in integer value and the other in float value, which includes a decimal point. If you wish to convert the values to strings, you can utilize the str function for this purpose. Simply wrap the variables with the str function to convert them into strings. However, when printed, the values will be concatenated together rather than summed because string values cannot be summed arithmetically. In Python, conditional operators help us compare values and figure out if given condition is true or false. For example, let's say we have a variable called marks. We want to see if the value of marks is more than 50. We can use conditional operators to find out. The greater than sign checks if the value of marks is more than 50. If it is, it returns true. If we change the value of marks to 40, it will return false because 40 isn't more than 50. But if we set marks to 50, it still returns false because the condition checks if the value is greater than 50. If we want to include 50 as true, we can use the greater than or equal to sign. Then, if marks is 50 or more, it returns true. We can also use the less than sign to check if the value is less than 50. Using double equal to checks if the value is exactly equal to something. If we want to see if it's not equal to something, we use the not equal to sign. These symbols help us compare values and conditions in Python to make decisions in our programs. The if statement is a fundamental control structure in programming used to make decisions based on certain conditions. It allows the program to execute specific code blocks if a specified condition is true. In simpler terms, the if statement evaluates whether a condition is met, and if it is, it executes a block of code associated with that condition. If the condition is not met, the program can proceed to other statements or execute alternative code blocks. Let's say we have a variable called marks. We will check if the value of marks exceeds to 80, the statement returns, "You got a 1 grade." We can associate more than one print statements if the condition is true. And if the value of the marks is greater than or equal to 70, then it will return "You got a grade." And if the value of the marks is greater than 50, then it will return "You got B grade." In any other case where the marks are less than 50, the statement returns, "Sorry, you have failed." This structure covers all scenarios based on the value of marks. We can also add the input function to input the value of the variable marks, and the if statement will return the grade after checking all the conditions. In Python, there are many tools called string functions that help change how data looks on the screen without altering the original value stored in a variable. For instance, if you want to make text appear in capital letters, you can use the upper function. Just remember to use the print function to display the result on the screen. Similarly, if you want the text to appear in small letters, you can use the lower function. You can use the find function to look for a particular letter in a sentence. It will tell you where that letter is in the sentence. For example, let's say we want to find the letter N in the sentence. The counting starts with the first letter as 0. So, if the letter N is at number 5, it means it's the fifth letter in the sentence. Similarly, if you're looking for the letter F, and it's at position 7, it counts even the empty spaces. Another helpful function is called replace function. It helps us change any letter or entire word within a sentence. For example, if we want to swap the letter R with a capital 1, we can use the replace function. Similarly, we can also change entire words using the replace function. For example, if we want to replace the word beginners with advance, it will change like this. Here is, the word beginners has been replaced with the word advance. You can use the in function to check if a specific letter or word exists in our sentence. For example, if we want to see if the word for is in our sentence, we can do it like this. It will give us an answer in the form of true or false. If the word exists in the sentence, it will return true, otherwise, it will return false. You can save the result of a string function in a new variable to use it anywhere in your code. For example, if we want to change our sentence to uppercase letters and keep the result in another variable, we can do it like this. The sentence in uppercase will be stored in a variable called topic2, and we can use this variable anywhere in our code. If you want to discover more string functions, you can visit the official Python website. Simply click on the String Methods section, and you'll find many different string functions listed there. A Python function is a block of reusable code that performs a specific task. Functions allow you to break down your code into smaller, manageable pieces, making it easier to read, understand, and maintain. Functions in Python are defined using the def keyword followed by the function name, parameters, if any, and a colon. The body of the function contains the code to be executed when the function is called. Here's a simple Python function that prints a greeting message whenever it's called. When you call greeting, it will print hello. Welcome to Python. You can call this function anytime you want to greet the user or display a welcome message in your program. Let's create a function named calculation that takes two parameters a and b. Inside the function, it calculates the sum of a and b and assigns it to the variable sum. It then returns the value of sum. The return statement ends the execution of the function and sends the value of sum back to the caller. When the function calculation is called with arguments 12 and 15. These values are passed to the parameters a and b respectively. The function computes the sum of a and b, which is 12 plus 15 is equal to 27, and returns this value. Finally, the print statement prints the returned value, 27, to the screen. In summary, the function calculation takes two numbers as input, adds them together, and returns the sum. The print statement then displays the result of this calculation. This function with the name of calc takes three parameters, val1, operator, and val2 inside the function. This function with the name of calc takes three parameters, val1, operator, and val2 inside the function. It checks the value of operator using if, elif, and else statements. If the operator is plus, it adds val1 and val2 and assigns the result to a variable called tot. If the operator is dash, it subtracts val2 from val1. If the operator is asterisk, it multiplies val1 and val2. If the operator is slash, it divides val1 by val2. If the operator is not one of the valid arithmetic operators, it assigns the string invalid operator or values. The function then returns the value of tot back. Here, the code prompts the user to input two integer values, val1 and val2, and an arithmetic operator, operator. It then calls the calc function with these inputs and prints the result returned by the function. A list is a versatile collection of items that allows you to store multiple elements of different types in a single variable. You have to use the print statement on data structures with specific number to achieve the desired results. In Python, you can create lists using square brackets with something separating the elements with commas. A while loop is a way to repeat a task based on a condition containing integers from 1 to 5. It's like a shortcut that helps us solve many problems easily. A while loop is a programming concept that allows you to execute a block of code repeatedly as long as a specified condition is true. Here's how it works. Condition. You start by defining a condition. To see all the items in a list, this condition is like a rule that decides whether the loop should continue running or stop. Execution. The block of code inside the while loop is executed if the condition is true. The first item of the list, if the condition is false, name with the index inside the loop is skipped. Every list starts counting from the next part of the program after the loop. If you want to access the first item of the list, after the block of code 0 as the index number executed, the condition is checked again. And if you want to view the second item of the list, if the condition is still index number, the block of code inside the loop is executed again. This process continues until the condition becomes false. And if you want to view the last item of the list, you should use -1 as index number. -1 always show the last item of the list, no matter how long your list is. And if you want to print all the items of the list on a separate list, you can use for loop. For loop through each item in the list called numbers. For each item, it puts that item into a variable called number, and then it prints out that item. It keeps doing this until it has looked at and printed out each item in the list. Let's explain the Python lists with another easy example. We have created a new list with the name of numbers and stored 4 fruit names in it. To view all the fruits in our list, we use the print statement followed by the name of our list. This prints out all the fruits listed one after another. If we want to see a particular fruit from the list, we can specify its position, known as its index number. But remember, in Python, counting starts from 0. So, the first item has an index of 0, the second has an index of 1, and so on. For instance, if we want to see the first fruit, we use 0 as the index number. To see the last fruit in the list, we use -1 as the index number. The -1 index always refers to the last item, -2 refers to the second last, and so on. If we want to see each fruit on a new line, we can use a for loop. This loop goes through each fruit in the list one by one and prints them out, each on its own line. In Python, a tuple is an immutable ordered collection of elements. This means that once a tuple is created, you cannot change its contents, add, or remove elements from it. Tuples are defined using parentheses and can contain elements of different data types, including other tuples. Here's a basic example of defining tuples. Tuples can also be created without parentheses, but it's a good practice to include them for clarity. You can add items of different data types in a tuple. We can view the items in the tuples using index number same like lists. The one major difference between list and tuples are the lists are editable, but on the other hand, tuples items can't be changed once they have created. For example, we have created a list with the name of list1. We will use append function to append a new item in the list. New item has been added in the list. But if we try to add a new item in the tuples, it returns an error that append can't be applied on tuples. We can also use for loop to access all the items within the tuples. Python dictionaries are a built-in data type that stores a collection of key-value pairs. The basic syntax for creating a dictionary in Python is by using curly braces and specifying key-value pairs separated by commas. In this example, name, age, and city are keys, while John, 30, and New York are values. You can access the values in a dictionary by providing the corresponding key inside square brackets. You can modify the value of any key like this. Or you can add any new key-value pair in dictionary. Python dictionaries are widely used for storing and accessing data efficiently, especially when you need to associate one piece of data with another, e.g., mapping unique identifiers to corresponding data values. They are versatile and offer a powerful way to represent data in Python programs. In the first example code, we will prompt the user to input 5 values, stores them in a list, finds the largest value from that list and then prints the result. Let's look at the code. This line initializes an empty list called values. This list will be used to store the 5 values inputted by the user. This line starts a loop that iterates 5 times. The loop variable I takes on values from 0 to 4. Inside the loop, this line prompts the user to input a value. Input is used to receive user input, and float is used to convert the input into a floating point number, a decimal number. The prompt message includes the iteration number I+1, so the user knows which value to input. This line appends the inputted value to the values list. In each iteration of the loop, the inputted value is added to the list. After the loop finishes, this line uses the max function to find the largest value among the elements in the values list. The max function returns the maximum value from the list. Finally, this line prints the result. It displays a message indicating the largest value found using the max function. Let's run this program and find the highest value amongst the 5 values. In this example, we have created a basic calculator program that can perform addition, subtraction, multiplication, and division. It asks the user to input 2 numbers and an operand. Then performs the specified arithmetic operation using the input numbers and operand. Let's dive into the code. For functions, add, subtract, multiply, and divide are defined to perform basic arithmetic operations. Add function will takes 2 numbers x and y as input and returns their sum. Subtract function will takes 2 numbers x and y as input and returns their difference. Multiply function will takes 2 numbers x and y as input and returns their product. Divide function will takes 2 numbers x, dividend, and y, divisor, as input and returns their quotient. It also checks if the divisor is 0 to avoid division by 0 error. The program prompts the user to enter 2 numbers, number 1 and number 2, and an operand to specify the arithmetic operation to be performed. Based on the operand entered by the user, the program determines which arithmetic operation to perform using a series of if statements. If the user selects the plus operand, then add function will be called and the values of number 1 and number 2 will be passed to x and y, and add function will return the sum of x and y. Similarly, if the user selects the subtract operand, then subtract function will be called and the values of number 1 and number 2 will be passed to x and y, and subtract function will return the result after subtracting the value of y from x. If the user selects the multiply operand, then multiply function will be called and multiply function will return the result after multiplying the value of x and y. If the user selects the divide operand, then divide function will be called and function will return the result after dividing the value of x with y. If the user entered an invalid operand, then the program will return the error message invalid operand. Finally, the result of the calculation is printed to the console. Let's run this program and perform some calculations. Let's try by entering a wrong operand. This program allows users to select a pizza from a menu, choose its size and toppings, specify the number of pizzas, and provides an order summary with the total price. It's a simple example of how you can implement a basic pizza ordering system in Python. Let's dive into the code and learn how this program is working. Display menu function. This function takes pizza menu as input and displays the available pizza options to the user. It iterates through the pizza menu list and prints out each pizza's name and price. Enumerate is a built-in Python function that allows you to loop over an iterable, such as a list or tuple, while also keeping track of the index of the current item. It takes two parameters, the iterable you want to loop over and an optional start index. By default, it starts from 0. Order pizza function. This function handles the pizza ordering process. It prompts the user to select a pizza by entering the corresponding number from the menu. Then it asks for the size of the pizza, small, medium, or large, and validates the input. The program performs basic input validation to ensure that the user enters valid options for pizza size, and selects a pizza from the menu. Next, it asks for toppings. The user can enter multiple toppings separated by commas, and it splits them into a list. After that, it asks for the number of pizzas the user wants to order. Finally, it calculates the total price based on the selected pizza's price and the number of pizzas ordered and prints out an order summary. In the order summary, the program will return the pizza name selected by the user with price, pizza size, topping, number of pizzas ordered by the customer, and finally the amount of the total order. Main function. This function initializes the pizza menu list of dictionaries containing pizza names and prices. It calls the display menu function to show the available options to the user. Then, it calls the order pizza function to take the user's order. Let's run this program and order a pizza. I am going to order the pepperoni medium pizza with olives topping. I want 2 pizzas. And here is my order detail with total amount. Let's try by adding a wrong pizza size. See, the program will not continue until you enter a correct pizza size. You can add multiple checks in your program to ensure that user is entering correct data. This program presents a list of 10 grocery items with their prices to the user. It then asks the user to select an item and specify the quantity. The user can continue adding items to their shopping cart or choose to finish shopping. At the end, the program will show the list of the items with quantity and price, and total of all the items at the end. Let's dive into the code to see how this program works. This is the main function where the program execution starts. We define a list named grocery items containing dictionaries, each representing a grocery item with its name and price. An empty list named cart is initialized to store the items selected by the user. There's an infinite loop, while true, to interact with the user and manage the shopping process. Inside this loop, we display the available grocery items using the show grocery items function. The user is prompted to select a grocery item and specify the quantity. The selected item is retrieved from the grocery items list and added to the shopping cart. The user is asked if they want to add another item. If they choose not to, the loop breaks. After the user finishes adding items, we display the items in the shopping cart along with their quantities and individual prices. The total amount for all the items in the cart is calculated using the calculate total function and printed to the user. Show grocery items function. The function takes one parameter, items, which is a list of dictionaries. Each dictionary represents a grocery item with its name and price. We print a header indicating that we are displaying the available grocery items. We iterate over each item in the items list using a loop. The enumerate function is used to generate a sequence of tuples containing the index and item from the list. We start the index from 1 to make it more user-friendly. Inside the loop, we print each item's number, name, and price formatted nicely using f-strings. The price is formatted to display 2 decimal places. By calling this function, we can easily display the list of available grocery items to the user with their corresponding prices in a clear and organized manner. Calculate total function. The function takes one parameter, cart, which is a list of dictionaries representing the items in the shopping cart. Each dictionary contains keys for name, price, and quantity. We initialize a variable named total to store the total amount for all the items in the shopping cart. This variable is initially set to 0. We iterate over each item in the shopping cart using a loop. Inside the loop, for each item, we calculate the subtotal by multiplying the price of the item by the quantity, and then add this subtotal to the total variable. After iterating over all the items, we return the total amount, which represents the total cost of all the items in the shopping cart. This function efficiently calculates the total amount for all the items in the shopping cart by iterating over each item and summing up their subtotals. Let's run this program and try to add 2 or 3 items in the shopping cart. Let's add bananas with quantity of 5. Now it's asking if you want to add another item in the list. We type yes. Second item we are going to add is chicken with quantity of 2. And third item we are going to add is rice with quantity of 5. Our shopping is completed, so I will type no. Here is our shopping summary, all 3 items with quantity, price and total. And grand total at the end of the list. So viewers, we've crafted a simple yet effective grocery purchase program. By analyzing this program, you'll gain a solid understanding of utilizing dictionaries, functions, and loops to create a comprehensive application. Stay tuned for our next exciting project. An object is simply a collection of data, variables, and methods, functions. Similarly, a class is a blueprint for that object. Python classes. A class is considered a blueprint of objects. We can think of the class as a sketch, prototype, of a house. It contains all the details about the floors, doors, windows, etc. Based on these descriptions, we build the house. The house is the object. Since many houses can be made from the same description, we can create many objects from a class. A class can be created by class keyword followed by class name, and then we will set the attributes of that class. For example, if we create a class with the name of car, then we can set its attributes like car make, its color, its gears, year of manufacturing and transmission. These attributes will be assigned to the objects created with this class. Python objects. An object is called an instance of a class. Suppose car is a class, then we can create objects like car1, car2 from the class. All the attributes of the class will be automatically assigned to the objects created by using that class. For example, we have created 2 objects car1 and car2 created by using car class, then all the specifications of the class like make, color, transmission, gears will be assigned to the both objects. We can assign different values to each object like this. We can access the attribute value of any object by using object name.specification. For example, if we want to view the make of object car1, then we can access the value like this. car1.make, and the result will be Toyota. And if we want to see the value of car2 object color, then we can access by using car2.color attribute. You can access any object specification by using this method. This code defines a class named cars with attributes for name, color, gears, and transmission. The cars class is a blueprint for creating car objects. It has 4 attributes initialized with default values. Name, initially an empty string. Color, initially an empty string. Gears, initially set to 0. Transmission, initially an empty string. Object instantiation. 2 car objects, car1 and car2, are created from the cars class. Setting object attributes. Car1 is set to represent a Toyota car with white color, 5 gears, and automatic transmission. Car2 is set to represent a Honda car with red color, 4 gears, and manual transmission. Output. 2 formatted print statements display the information about car1 and car2. The first print statement describes car1, indicating that it is a white Toyota with 5 gears and automatic transmission. The second print statement describes car2, indicating that it is a red Honda with 4 gears and manual transmission. Overall, this code creates 2 car objects with different attributes and prints a description of each. It demonstrates basic class definition, object instantiation, attribute assignment, and formatted output in Python. Constructors in Python. In Python, a constructor is a special method in a class that is automatically called when an object is created or instantiated. It is used to initialize the attributes of the class with default or specified values. This process is commonly referred to as object initialization. Here's a more detailed look at Python constructors. Purpose of a constructor. The primary purpose of a constructor is to set up the initial state of a new object. It typically assigns values to the object's attributes, performs any necessary setup, and may even validate the input parameters. In Python, the constructor method is named __init__. Defining a constructor. You define a constructor within a class using the __init__method. It is automatically called when a new instance of the class is created, and it usually accepts parameters that are used to initialize the object's state. The first parameter of the constructor is typically self, which refers to the instance being created. For example, a person class has two attributes, name and age. The both attributes will be assigned to the object automatically, which is associated with class person. Here's an example of a class with a constructor that initializes some basic attributes. Class definition. A class named person is defined with a constructor method init and an instance method introduce. The constructor initializes the object with two attributes, name and age. It takes two arguments during object creation and assigns them to the instance's attributes, self, name and self, age. The introduce method, an instance method, uses the initialized attributes, name and age, to return a formatted string introducing the person. A new instance of the person class named person1 is created with the name Alice and age 30. This instance creation calls the init constructor, initializing person1 with those values. The introduce method is called on person1, which returns the introduction message containing the name and age of the person. The print function outputs the returned introduction message, which in this case is, "Hi, I'm Alice and I'm 30 years old." This code snippet illustrates the core concepts of object-oriented programming in Python, defining classes, initializing object attributes, creating instances, and calling methods. It shows how classes can be used to encapsulate attributes and behaviors for a concept, in this case, a person with a name and age. This code snippet defines a class called addition that encapsulates the logic for adding two numbers and then displays the results. It demonstrates several key concepts in Python: class definition, parameterized constructors, instance attributes, instance methods, object instantiation, and interaction with class instances. Here's a detailed breakdown of the code. Class definition. Addition class. The addition class has three class-level attributes initialized with default values. First is set to 0. It represents the first number for addition. Second is also set to 0. It represents the second number for addition. Answer is initialized to 0. This will store the sum of first and second. The constructor initializes the instance with given values for first and second. The parameters f and s are passed to the constructor during object creation, setting self.first and self.second to these values. Display method. This method outputs the values of first, second, and answer in a formatted manner, using the print function. It provides information on the numbers involved in the addition and the calculated result. Calculate method. This method performs the addition of first and second, storing the result in the answer attribute. Object instantiation and operations. Creating objects, obj1 and obj2. Obj1 equals addition, 1000, 2000. This creates an instance of addition with first equals 1000 and second equals 2000. It calls the parameterized constructor, initializing these attributes. Obj2 equals addition, 10, 20. Another instance of addition with first equals 10 and second equals 20. Calculations and results. obj1.calculate calls the calculate method on obj1. This sets obj1.answer to 1000 plus 2000 is equal to 3000. obj2.calculate calls the calculate method on obj2. This sets obj2.answer to 10 plus 20 is equal to 30. Display outputs. obj1.display displays the values of first, second, and answer for obj1, showing the addition result. First number equals 1000, second number equals 2000, addition of two numbers equals 3000. obj2.display, similarly, displays the results for obj2, with an output, first number equals 10, second number equals 20, addition of two numbers equals 30. Overall, this code demonstrates creating a class to perform a simple task, addition, constructing objects with specific parameters, calculating results, and displaying them. It reflects a basic structure for encapsulating and reusing logic in object-oriented programming. This code defines a class named Cars with attributes for name, color, gears, and transmission. The cars class is a blueprint for creating car objects. It has 4 attributes initialized with default values. Name, initially an empty string. Color, initially an empty string. Gears, initially set to 0. Transmission, initially an empty string. Object instantiation. 2 car objects, car1 and car2, are created from the cars class. Setting object attributes. Car1 is set to represent a Toyota car with white color, 5 gears, and automatic transmission. Car2 is set to represent a Honda car with red color, 4 gears, and manual transmission. Output. 2 formatted print statements display the information about car1 and car2. The first print statement describes car1, indicating that it is a white Toyota with 5 gears and automatic transmission. The second print statement describes car2, indicating that it is a red Honda with 4 gears and manual transmission. Overall, this code creates 2 car objects with different attributes and prints a description of each. It demonstrates basic class definition, object instantiation, attribute assignment, and formatted output in Python. Constructors in Python. In Python, a constructor is a special method in a class that is automatically called when an object is created or instantiated. It is used to initialize the attributes of the class with default or specified values. This process is commonly referred to as object initialization. Here's a more detailed look at Python constructors. Purpose of a constructor. The primary purpose of a constructor is to set up the initial state of a new object. It typically assigns values to the object's attributes, performs any necessary setup, and may even validate the input parameters. In Python, the constructor method is named __init__. Defining a constructor. You define a constructor within a class using the __init___ method. It is automatically called when a new instance of the class is created, and it usually accepts parameters that are used to initialize the object's state. The first parameter of the constructor is typically self, which refers to the instance being created. For example, a person class has 2 attributes, name and age. The both attributes will be assigned to the object automatically, which is associated with class person. Here's an example of a class with a constructor that initializes some basic attributes. Class definition. A class named person is defined with a constructor method init and an instance method introduce. The constructor initializes the object with 2 attributes, name and age. It takes 2 arguments during object creation and assigns them to the instance's attributes, self, name and self. Age. The introduce method, an instance method, uses the initialized attributes, name and age, to return a formatted string introducing the person. A new instance of the person class named person1 is created with the name Alice and age 30. This instance creation calls the init constructor, initializing person1 with those values. The introduce method is called on person1, which returns the introduction message containing the name and age of the person. The print function outputs the returned introduction message, which in this case is, "Hi, I'm Alice and I'm 30 years old." This code snippet illustrates the core concepts of object-oriented programming in Python, defining classes, initializing object attributes, creating instances, and calling methods. It shows how classes can be used to encapsulate attributes and behaviors for a concept, in this case, a person with a name and age. This code snippet defines a class called addition that encapsulates the logic for adding 2 numbers and then displays the results. It demonstrates several key concepts in Python: class definition, parameterized constructors, instance attributes, instance methods, object instantiation, and interaction with class instances. Here's a detailed breakdown of the code. Class definition. Addition class. The addition class has 3 class-level attributes initialized with default values. First is set to 0. It represents the first number for addition. Second is also set to 0. It represents the second number for addition. Answer is initialized to 0. This will store the sum of first and second. The constructor initializes the instance with given values for first and second. The parameters f and s are passed to the constructor during object creation, setting self.first and self.second to these values. Display method. This method outputs the values of first, second, and answer in a formatted manner, using the print function. It provides information on the numbers involved in the addition and the calculated result. Calculate method. This method performs the addition of first and second, storing the result in the answer attribute. Object instantiation and operations. Creating objects, obj1 and obj2. Obj1 equals addition, 1000, 2000. This creates an instance of addition with first equals 1000 and second equals 2000. It calls the parameterized constructor, initializing these attributes. Obj2 equals addition, 10, 20. Another instance of addition with first equals 10 and second equals 20. Calculations and results. obj1.calculate calls the calculate method on obj1. This sets obj1.answer to 1000 plus 2000 is equal to 3000. obj2.calculate calls the calculate method on obj2. This sets obj2.answer to 10 plus 20 is equal to 30. Display outputs. obj1.display displays the values of first, second, and answer for obj1, showing the addition result. First number equals 1000, second number equals 2000, addition of two numbers equals 3000. obj2.display, similarly, displays the results for obj2, with an output, first number equals 10, second number equals 20, addition of two numbers equals 30. Overall, this code demonstrates creating a class to perform a simple task, addition, constructing objects with specific parameters, calculating results, and displaying them. It reflects a basic structure for encapsulating and reusing logic in object-oriented programming. As our program grows bigger, it may contain many lines of code. Instead of putting everything in a single file, we can use modules to separate codes in separate files as per their functionality. This makes our code organized and easier to maintain. Module is a file that contains code to perform a specific task. A module may contain variables, functions, or classes. Let's see an example. Let's create a new file with the name of calculation. In the calculation file, we have defined a function add, inside the calculation.py file. The function takes in two numbers and returns their sum. We can use the import keyword to import any module in another file. We have created a file with the name of calculation.py, so we can import our module by using import command like this. Import calculation. Now after importing the module, we can use all the functions defined in the calculation.py file. We have created add function earlier, we can use this like this by using print statement. Print module name. Function name and arguments which will be passed to get the results. Let's call the add function again to calculate once more. Remember, if you used any other symbol instead of comma between the two values, it will return the error. So always use comma to spare it the values. Our module is working fine. We can directly add the specific function from module, and in this way we don't need to write the module name each time when we call the function, we just need to call the function directly. We can import a specific function by typing from module name import function name. In our case, Our module name is calculation and our function name is add, so we can import our function directly like this. Now we don't need to add the method name in beginning of the function add, so I am going to remove this. Now our function is working fine. If you want to add all the functions defined inside the calculation module, you can use asterisk to import all the functions. So guys, this is how we can create a new module and used it in another file. In the next exercise, we are going to learn how can we perform all the math calculation like add, subtract, multiply and divide by using a module. Let's extend our module to add the more functions. In the previous exercise, we created a module named add. Now, we're extending this module by adding new functions. First, let's implement the subtract function. This function will take two arguments, a and b, and return the result of subtracting b from a. Next, let's define the multiply function, which takes two values and returns their product. Finally, let's implement the divide function to divide two values. To use these functions, we need to import them. We can either import specific functions or import all functions using the asterisk sign. Once imported, we can utilize these functions in our code. Let's start by adding two values using the add function. For example, 10 plus 20 equals 30. Next, let's use the subtract function. For instance, 50 minus 20 equals 30, indicating that our second function is working correctly. We can also customize the names of the imported functions. For instance, if we frequently use the subtract function, we can import it with a shorter name like sub. This makes it more convenient to use throughout our code. It's essential to note that these custom names are valid only within the file where the module is imported. If you intend to use these functions in other files within your project, you'll need to import the module using the import function. Moving on to the third function, let's use multiply. Multiplying 10 by 10 gives us 100. Lastly, let's employ the divide function. Dividing 50 by 10 results in 5. You can also customize the name of the divide function upon import. and it will function the same way as the original divide function. Let's enhance this code and add an if condition, so that we can perform all type of calculations by entering the values and an operand like plus, minus, divide or multiply. So I am going to add if conditions in my code. This code will accept two inputs from the user and then ask the user what he wants to do, and perform the calculation as per operand given by user. And if the user given a wrong operand, then it will return the error, invalid operand. Let's execute this code to perform calculations. We'll input two values and an operand to specify the operation. For instance, if we want to add the values, we'll use the plus operand. We've entered two values 10 and 20 and an operand to add them. The result is displayed correctly. Now, let's test the code with other operands. Let's subtract 30 from 50. And it's showing the correct result. Let's divide 100 with 20. And it returned the answer 5. Now, let's try an invalid operand. I am going to give underscore as operand. As anticipated, we received an error message indicating an invalid operand. Our code is functioning properly. In this video, we will cover different methods for getting date and time using the datetime module and time module in Python. Later in this video, we will learn how to create a digital clock using a Python module. Let's dive in. This code retrieves the current date and time using the now function from the datetime module in Python. Here, the datetime module is imported, which provides classes for working with dates and times in Python. The now function from the datetime module is called. This function returns a datetime object representing the current date and time. The now variable stores this datetime object. Finally, the print function is used to display the value of the now variable, which contains the current date and time. When you run this code, it will output the current date and time. Here is another example, in which we can retrieve the current date using the datetime module. This line imports the datetime module in Python. The datetime module provides classes for working with dates and times. Here, the today function from the datetime module is called. This function returns a datetime object representing the current local date. The current date variable stores this datetime object. Finally, the print function is used to display the value stored in the current date variable, which contains the current local date. This code snippet utilizes the date class from the datetime module in Python to work with dates. Let's break down the code. This line imports the date class specifically from the datetime module. The date class represents a date, year, month, day, in the Gregorian calendar. The today function is called on the date class to obtain a date object representing today's date. This object is assigned to the variable today. These lines print the year, month, and day of today's date, respectively. They access the attributes year, month, and day of the date object today and display their values. When you run this code, it will print the current year, month, and day of the system state. This code will display the calendar for the current month and year. Let's break down this code. Importing necessary modules. DateTime, this module supplies classes for manipulating dates and times. Calendar, this module allows you to output calendars and provides various functions related to the calendar. The today function from the DateTime.date class is called to retrieve the current date. It returns a date object representing today's date, which includes attributes like year, month, and day. Here, the year and month attributes of the date object today are accessed and assigned to variables y and m respectively. These variables store the current year and month. The month function from the calendar module is used to generate a formatted text representation of the calendar for the specified year, y, and month, m. This function returns a string containing the calendar, which is then printed to the console using the print function. If you want to print the calendar of any other month, just change the value of month variable. For example, I want to display the June calendar, then I have to write the in numbers like this. This code creates a simple clock application using the tkinter library in Python. Let's go through it step by step. Importing necessary modules. Tkinter, it is the standard GUI toolkit for Python. Tkinter.ttk, it contains themed tkinter widgets that have a more modern appearance. Time, it provides various time-related functions, including strifttime, which is used to format time. This creates a tkinter window with the title clock. This function retrieves the current time using strifttime, which formats the time as hours, minutes, seconds, and AM/PM. It updates the text of the LBL label widget with the current time. LBL. After 1000 time schedules the time function to be called again after 1000 milliseconds, 1 second. Styling the label widget. This creates a label widget, LBL, with a specified font, background color, and foreground color. Placing the clock label. This places the label widget, LBL, at the center of the tkinter window. Calling the time function and running the tkinter event loop. Time is initially called to start updating the clock. Main loop starts the tkinter event loop, which waits for events, like button clicks or window resizing, and processes them. When you run this code, it will create a simple clock GUI displaying the current time with a purple background and white text. The time will update every second. So viewers, here is how we can create our own module, or we can use predefined Python modules to perform several tasks.